Well, today's question is we are getting it from that's KASNEB, CPA foundation level, CIFA foundation level, that's quantitative analysis. The paper was done on 3rd August 2022. That was on Wednesday. And the question of interest is question 6A and B. So straight away, question 6 is here. Part A, outline 4 qualities of a good average. That's 4 marks. Part B, the weights of 1,000 items are normally distributed with a mean of 200 kgs and a standard deviation of 22 kgs. Determine the number of items that have weights between 210 kgs and 220 kgs. That's 2 marks. Roman 2, determine the number of items that have weights between 180 kgs and 230 kgs. Roman 3, calculate the weight below which 20% of the items fall. 2 marks. So that's the question, and we move straight away to see what the solution looks like. Well, this is the answer to part A of that question, where we asked outline 4 qualities of a good average. Average is the mean. And so one advantage of the mean is that it reflects the central tendency of the data set. Now, if you handle your data so well and you clean it so that you remove the outliers, then what you're going to get at the average out of the data set should be representative and not misleading. So every other time that you carry out such an experiment using different samples, you are going to get a mean which you are going to get different means which are closely packed 95 times out of 100 trials that you make. So that's representativeness. So in simple terms, it reflects the central tendency of the data set. That is, if not affected by outliers. Second, it is simple. That is simplicity. It is easy to understand and calculate, thus accessible for broad use. You simply add the number, you simply add the values and then divide by the size. Consistency. The same average should be obtained if the data set is randomly sampled multiple times. Like I explained in representativeness, we always talk about confidence interval of 95%. That should mean that if you worked out a mean out of a clean data, which is not affected by outliers, then should you carry out several experiments using different samples, say 100 samples, then out of those 100 samples, we are expecting 95 of them to be consistent with the mean that you worked out, and only 5% of them should be outside the mean with a defined standard deviation. So consistency here is another key term. Then stability, it is not significantly affected by minor changes or variations in the data set. And that's why we are able to define a confidence interval. Normally we define a confidence interval means that we are expecting, if it's the mean, by defining a confidence interval, we are simply saying that we expect it to lie between this particular value and this particular value. So we give it a range. Now, giving it a range means that we can tweak. There can be changes in the original observations, but those changes will not necessarily affect our mean as worked out from the population. So that answers part A of question 6, and we proceed to part B. Welcome to another session of revision of quantitative analysis KASNEB exams. The question that we want to consider, as you have seen, is that which was taken on 3rd August of 2022. It is question 6. And in this case, I'll consider question 6A and question 6B because we are going topical. So this part, I'll then jump to part B, being that we have seen what part A is. So Part B is the weights of 1,000 items. 1,000 items. That's where we start from. So N is 1,000. So you collect data from the first sentence you read from the question. So N is 1,000. Items are normally distributed with a mean of 200 kilograms. So mean is 200 kilograms. And a standard deviation of 22 kilograms. Determine the number of items that have weights between 210 kilograms and 220 kilograms. So we remember straight away that Z is equal to X minus mu over this. And so we want the probability. If we draw it, we first need to see what it looks like. So this is what we have. If that's the curve, then we are saying the mean is somewhere here, which is 200. And we are saying there is, the question is asking us to determine the number of items that have weights between 210 and 220. So 210 should be somewhere here, actually beyond the mean. That's 210. And let me say 220 somewhere here. So there's 220 here. 220, well, it's not visible, but I can't, well, if I wrote it, you may not see it, but this, if this point is 200, this is 200, it's the mean, then we have this to be 210, and then this line to represent 220, 220. Then we want this probability, we want the area, this area. Once we get this area, then we'll multiply this area by 1,000 items, and that shall have answered our Roman 1. So, how do we get it? First, Z of 220 will be 220 minus 200 over 22. And that is, then Z of 210 is equal to 210 minus 200 all over 22. And that's, so what we are going to get is here, 210 minus 200. In this case, we are going to get a Z of 0.4545. That's the Z that we are referring to. And then for this, that's if you work this out, which is 210, that's 10 over 22 gives you that. Then this will be 20 over 22, which should give you 20 over 23, 0.9091. So that's what we have here, that's what we have there. So if we were to get that difference, then definitely what we are going to do is to subtract this from that. So the next thing that we do is, already these are the Z's for. So what we do is that if this is Z of 2020 is this, and Z of 210 is this. So for us to get this area, we will read the probability that corresponds to this Z score from our table, in which case we would call that probability of Z 2020. If you read it, if you read a probability that corresponds to this, it will give you 0.8186, 0.8186. Probability that corresponds to this Z score, that's of 210, will be, that's Z of 210, will be 0.6754. So in other words, what we are saying, the area from this tail to 210 is 0.6754. And the area from this tail to 220 is 0.8186. So for us to get the shaded area, we'll have to subtract this from this, which will be 0.8186 minus 0.6754. And if you get this, if you work out that difference, you should get, if you work out that difference, you should get 0.1432. 0.1432. Now, that's this area and it's the probability. So if you want to get the number of items as the question instructs us to do, then we would have to multiply this by 1,000, in which case we say it's approximately 143 items. That's the answer to Roman 1, approximately 143 items. Then we proceed to Roman 2. Roman 2 requires us to answer, determine the number of items that have weights between 180 kilograms and 230 kilograms. So we would follow just the same procedure. And here we say Z of, now there's an advantage to a student who knew the first one, who would straight away score the Roman 2. So Z of, it is Z of 230, 230, and Z of 180. So this will be 230 minus 200 over 22. This will be 180 minus 200 over 22. What's that? So if we check what those values will be, for Z180, the difference, this being that this is greater, you'd expect approximately negative 0.9091. That's the Z value that corresponds to that. The Z value that corresponds to Z of 30, read from the table, should be 1. No, not read from the table. If you work out this, the difference between this and this divided by this is 1.3636. Those are the two Z values. Now, I want the probabilities that corresponds to them. So probability that would correspond to Z of 230, will be probability that corresponds to Z of 230. That's by reading this. It will be 0.9131. This is read from the tables in line with this. This is the Z score. So this probability is read from the tables. Then probability of Z2, 180 will then be, if you read probability that corresponds to this, of course it's negative because it's on the other side of the tail. So if you check that probability, you'll get it to be about 0.1814. 0.1814. So probability is not negative. So if you want to get a value of interest, it will be 0.9131 minus 0.1814, and that should be 0.7317. 0.7317. So that is the probability between them. So that if I had 180 here, okay, let me see. So if this is the mean 200, if this is, let me say the mean is here 200, to be 200, the mean is 200, and this end is 230. Then I come and get some 180 here. So I'm referring to the entire shaded part. So we're just saying that this total part that I've shaded is about 73.17%. 73.17%. That's what I'm saying. So if that's the case, then I would have to, if what is required is the number, then I would have to multiply this by 1,000 to get the number. In which case, it will be approximately 732 items. So that will be approximately, multiply this by 1,000, approximately 732 items. So that answers Roman 2. That answers Roman 2. This was Roman 1. This is Roman 2. And now we have Roman 3. Calculate the weight below which 20% of the items fail. calculate the weight below which. So no, I still need this. I need that. What I don't need is this. Now, here I said N is 1,000, mean is 200, standard deviation is 22. But then I'm asked, calculate the weight below which 20% of the items fail. So I want the picture first, if that's the picture. If that's the picture, then what we'll have, if that's the picture, then I will have here as 200, our 200 that we know. And if this is the mean, then that weight should fail below. So I would have it here. I would have it beyond, on the left of the mean. On the left of the mean. And then I call it X. I don't know it, X. I don't know that weight, it's X. But then I'm asked to calculate the weight below which 20% of the items fail. So I'm told that this should be 20%. This should be 20%. This is 20%. So if this is 20%, I would then read the probability value, the Z-score that corresponds to this probability from my table. So what I'm going to do is I say Z is equal to X minus mean, which is 200, all over 22, which is our standard deviation. But we want a Z value that corresponds to 20% from our table. If we read that Z value, the Z score that corresponds to the bottom 20%, that is the bottom 20%, is approximately, it's going to be a negative because this is definitely beyond the mean, on the left of the mean. So that Z score is negative 0.8416, as we see from the table. So how we do it, I'm going to show you towards the end of this class. So here it means that I just make this the subject. So I have that. This should imply that X minus 200 is equal to 22 times minus 0.8416. That should imply that X is the whole of that is 22 times negative 0.8416 plus 200. If it crosses the other end, it becomes that. And my X value, if I work it out, bearing in mind that this is going to be a negative, so we expect an X which is less than 200, because we are going to effectively subtract what we get here from this, owing to this sign here. So that value is going to be about 181. That's the difference between 200 and this, 181.48 kilograms. So that is X. So our X, 181.48 kilograms, is somewhere there. So that answers the question for that particular here. Up to that end, I urge you to subscribe so that you continue getting such content, because I'll be releasing them each and every day. Thank you, and see you in another video. Well, now the Z values that we are given, the Z value that corresponds to when the reading is 210 kgs is 0.4545. If we check the corresponding probability from the table, we have Z here, there's 0.45. 45 will be here, but it's 45. So I will then move to 5. Okay, if I have that, let me just highlight. So this is 0.45, but then I have 45. So I'll I'll round it up to 5. So then I come here and get 18. So add 18 to 0.6736. 0.6736 plus 18. That should give me 0.6, should give me a reading value of 0.6754 as the corresponding probability value. Then if we check the Z of 0.9, the corresponding probability reading should be, so if we have 0.91, let me call it 91. So, okay, 909. So we are here, 90, we are here. That gives me 0.8159. But then 0.90923. So if I add 23, if I add 23 to this value, that should give me about, that is 0.8159 plus 23. That is 27818. That's about 0.8182. 8182. So that's the corresponding probability. In our book, in our workings, we have 0.8186. Yeah, that's a slight variation. Then that's that. Then we have Z of 180, where we have now minus 0.9091. Being that it's a minus, it indicates that it was on the left-hand side of the mean. And so the probability that we just got when Z was 0.9091, we subtract it from 1 to give us the right probability here. So 1 minus 0.8182 or 8186, as we found it there, should give you about 0.1814. And that's the corresponding probability that corresponds to a Z reading of negative 0.9091. Then there's a Z reading of 1.3636 as we saw. And if we check here again, 1.336, 1.3, then we get 6 here, highlight, 36. So I want to get to 4, which is 6. So I there, that gives me 0.913. Okay, 1.366 is here, but then I take 4, another 6. So that gives me 0.9137. 0.9137. That's what I get as the corresponding probability. In our case, it's 0.9131. Now that slight variation comes about as a result of rounding off. It's advisable to round off at the tail end when you have the answer, not when you are still in the process of your workings. That will lead to propagation of errors, and it's not advisable. In some cases, it leads to penalty. Examiners will penalize you for rounding off before you get to the answer. Then the last bit is the Z score that corresponds to the bottom 20%. The bottom 20%, that should be about 80%. Bottom 20%, meaning we are here. We are here. Bottom 20%. That bottom 20%, being that this probability is defined between 0 and Z, will get it as a reading corresponding to 0.8. Now, if we check a reading that corresponds to 0.8 inside our table, we find this is close. but we are still not there yet. We need about 5 to get it to 0.8, but we find that 5 here. So it means that our reading is 0.842. 0.842. That is our reading. So 0.842 becomes our the actual reading that we want. But being that it's on the left hand side of our mean, which is 0, in this case, we then take it to be a negative. So the z value in that the z value that corresponds to 20%, bottom 20% is approximately negative 0.8416. And I think that's the end of the work of normal distribution, as I promised to consider at the end of this lesson. So up to there, we meet in my next video.